Hi all, we're going to get started in about 10 seconds. Welcome to the Monday afternoon session of the J Champions Conference. We're going to hear a quick note from Oracle before we get started.
Good morning. I'm Jennifer Nicholson with Oracle, and I want to welcome you to the J Champions Conference, which is organized by Java Champions with all Java Champion speakers. Over 4 days of sessions on January 13th and 14th and 18th and 19th, you will hear from 28 different Java Champions. So who are these Java Champions? Well, they are a select group of over 300 technical luminaries who are leaders in the Java community. You can find a list of Java Champions and learn more about the award at developer.oracle.com/Java Champions. So thank you for being a part of the first J Champions Conference and for your partnership in making Java the #1 programming language and development platform in the world as we continue to celebrate its 25th anniversary. Now grab your favorite beverage, get comfortable, and enjoy one or all of these 24 different informative sessions. Thank you.
Thanks. As Nikhil starts to share his screen, I'm going to give a very brief introduction. Nikhil is a director and senior principal architect in application development at BNY Mellon out in Texas. He is going to be telling us today about Kafka. Take it away, Nikhil.
Thanks, Jean. I hope everyone is having a wonderful Monday, and I hope all of you had a very grand weekend. So with that, I'm going to get started with Kafka. As Jean introduced myself, my name is Nikhil Nanivadekar, and today's session is getting started with Kafka. I'm also one of the project leads of the open source collections framework called as Eclipse Collections. The website for that is eclipse.org/collections out here, and the GitHub repository for the same is github.com/eclipse/eclipse-collections. This is a completely hands-on talk where I'm going to discuss the fundamentals of Kafka, and I'm going to do it in a demo-based fashion where I introduce concepts and do live demos for the same. I would prefer to have all the question answers towards the end. However, that said, in order to help the audience keep the context, I will be pausing between multiple sections to take questions, and Jean will be moderating them. If there are any questions to which I don't get to today, you can always tweet me at my Twitter handle, Nikhil Nanivade, and I'll be happy to answer those questions there, as well as answer questions offline. So with that, let's get started with Kafka. So the very first and foremost question is, what is Kafka? So there are many definitions or many ways in which Kafka is understood in our day-to-day programming life, or like in our day-to-day usage of Kafka. But in essence, Kafka is nothing but a transaction log. And the reason why I call it a transaction log is because it's essentially similar to the database transaction log that you have. So what that means is the source of truth in terms of data comes from the transaction log. Now, because it is essentially a transaction log, what ends up happening is Kafka delivers some features which become important for our ecosystem and the way in which we adopt Kafka. So let's look at some of them. Kafka guarantees ordering for every partition in a topic, and we will understand I'll explain what partition and topic is as we go on with that. The next thing is Kafka guarantees guarantees delivery as long as n-1 nodes or servers, n-1 servers are available. And again, we will understand what these are in a minute. But it is important that you at least know these three. Additionally, Kafka has multiple components, but the the main components which make the entire ecosystem work correctly is Zookeeper, and I will go through each and every one of these components in a minute. Then the broker, or as we call server. Kafka servers in Kafka topology is always called as a broker. Then the producer, consumer, and sorry, before the producer comes the topic. Okay, so these are the individual components in a Kafka topology. Now we will look at each and every of these in a very abridged way, and then I'll do a demo to explain these individual components. So let's look at Zookeeper first. The reason why Zookeeper is required in our Kafka ecosystem is because all the configs, the responsibility to store the configs, the responsibility to store the configs, or rather retain the configs is of Zookeeper. And here when I say configs, I mean in terms of everything, in terms of brokers, in terms of topics, in terms of producers, consumers, etc., etc. Then the next one is the responsibility of electing a leader, okay, in a Kafka cluster is of the Zookeeper. Okay, Zookeeper. And then last but not the least, Zookeeper has the responsibility to ensure that data is replicated to all the necessary nodes, and the way it essentially ensures is it keeps a list of the offsets that every single node has. And again, we are going to go through all of these concepts in a moment, so just bear with me for a second. Okay. The next one is the broker or the server. So the Kafka broker or the server is nothing but our normal server. Okay, so a Kafka broker or a server is that component where essentially the Kafka topic resides, and thereby the data which is published to the topic. Okay, when it comes to a Kafka broker ecosystem, you have the ability, and this is what you will generally do in production, is you will have more than one server, more than one Kafka server be a part of your Kafka cluster. And because you have more than one server or Kafka broker be a part of your cluster, that becomes the responsibility of Zookeeper to understand which all essentially brokers, so that's where the config retention comes into picture, which all brokers are a part of that cluster. And with that, we'll go to the next one, which is called as the topic. So a Kafka topic is nothing but a logical separation of messages. And a Kafka topic is a concept wherein let's say you have multiple different types of messages. In order to make sure that they are separated logically or by a business functionality, you have that logical separation. Now, every single topic contains at least one partition, which is like a non-partition topic. But in order to increase parallelism, you normally have partitions. So a topic is further divided into partitions. Okay, and what essentially the partitions function as is it helps you in parallelism, because whenever a Kafka producer publishes messages to a Kafka topic, it can go, like, Kafka ensures that it goes to one of the partitions that are available, and then the consumer can pick up these messages from these partitions. So the higher the number of partitions, higher higher is the possibility of parallelism or parallel consumption for the consumers. And I will explain what this is in a second when we are looking at consumers. Now, if you remember before, I said that it guarantees ordering for every partition in a topic. So what that means is within this partition, all the messages that you have been published are in that same order in which they were published. So it's similar to like a messaging queue where all the messages are published and they will be picked up one after the other in an order in an ordered way. Okay. The next one is a producer. A producer is a system which produces messages and publishes them to a particular topic. Okay. Now, this is where the interesting point comes. So when I say particular topic, in parenthesis, it will be topic and partition, because by default, you can just publish a message to a topic and leave it up to Kafka to do the distribution across partitions, or you have the ability to publish it to a very specific partition as well. Both of them have their pros and cons, and depending on your use case, you have to use one or the other. Last but not the least is the consumer. So a consumer is which consumes messages from a particular topic. Okay, and I should say and partition as well, because similar to the producing side, where you can just publish your message to a topic and then Kafka will take the responsibility of distributing it to and putting it on a particular partition. On a consumer side, you can just subscribe to a particular topic, and then Kafka will make sure that depending on the number of consumers, you can actually get the data out across one or more partitions. There are a few things that you need to keep in mind when you're looking at consumers and when you're looking at partitions, and I'm going to list them. I'm going to list the most important thing right now for us, because this comes into play a lot, and I don't want to miss it in case we run out of time. So one of the very most important concepts of parallelism, consumption, and partitions is that one partition can be consumed by only one consumer. Okay. However, one consumer can consume from multiple partitions, and we are going to look at partitions, and we are going to look at it with real life demo if we have enough time. However, this is something very important. One partition, or rather one consumer, can consume from multiple partitions. However, one partition can only deliver messages to one consumer, and we'll see that in actual practice in a minute. So let's actually dive into the demo and look at each one of these components, because I know that in the last 12 minutes I did give a lot of information, and I think for the interest of the audience, we should understand and look at every single of these components. So if you see here, I'm just going to start, and again, you can just go to the Confluent website, and actually they have amazing katas which walk you through Kafka itself. But if you want to follow along with this talk after it's on YouTube and like look at it one after the other, you can just download the Kafka installation, and then all I'm doing is running their what do you say their scripts. Like, I haven't written anything special. So first and foremost, what I did was I started my Zookeeper, and if you see here, I have a ton of output log, but we don't have any interest in that for a second right now. The second thing that I'm going to start is our broker or our server. And now if you see, as the server will start, you will see in a second that essentially this server has the configuration available in server.properties to connect to the Zookeeper instance, which we actually turned on. And as you can see, this is my broker ID, etc., etc. But if I go back to my Zookeeper instance, you can parse out the logs and basically know that like the Kafka broker is connected to that Zookeeper instance. The interesting thing about Kafka is the amount of resources or the amount of data that you can retain on a Kafka broker directly depends on the amount of file space that you have or the disk space that you have in your system. Because like I said before, Kafka is nothing but a transaction log. So what Kafka goes on doing is all the messages, they are essentially stored just as logs, and Kafka has the ability to go and read those messages and deliver them. So the next thing is actually creating a topic. In this case, I'm going to create a topic called as test. I'm going to create a topic with just one partition over here, as you can see, partition 1, and replication factor as 1. Replication factor is where the redundancy comes into picture. If I had more than one server, I could actually have more the replication factor as more than 1. And this was where I had explained here that Kafka guarantees delivery as long as there are n-1 brokers available. And here n is your replication factor. So in this case, our replication factor is 1 because we just have one server right now. But normally in a production environment or in an integrated environment, you will generally have more than one Kafka broker who is a part of a cluster, and you will have more than one as replication factor just in case one of those servers go down, and then you have to do some DR activities and everything so that you don't lose any data. But that's like more in depth, more than getting started. I just wanted to mention that for just FYI. So I'm going to start creating the test topic, and if you see, it created a topic test. Now, as I mentioned before, Kafka topics are nothing but logical separations. So the reason why you need logical separations, and look at this like as an example in real life. Okay, when travel was there, or rather prior to COVID, we had different means of travel, like to go from place A to place B. One was via road, train, via ship, then via airplane. Right now, like imagine having a ticketing system where all the 4 modes of transportations were going across in one single topic, but each of the topics are responsible each of different systems, like the air system is responsible for just consuming the messages which are required for air. The train system, so on and so forth, is responsible for consuming the messages related to the trains, and so on and so forth for like buses and ships, etc., etc. Now, what's going to happen is, because Kafka ensures that the messages are always kept in order, what will have to happen for all of these systems to essentially read the messages and get to their appropriate or their required messages is they would have to consume all of these unnecessary messages. Like the plane system, like the flight system will have to consume the messages related to trains, buses, ships, or boats, and then get to air, and depending on whichever order that they're published. Now, that becomes highly inefficient. So in order for that, Kafka has this concept for logical separation called as topic. So in an ideal Kafka topology, you would have 4 different topics. One is for flights, the other one is for trains, then for ships, and then for road or like buses or something. And essentially, it will be the producer's responsibility to publish the messages to the appropriate topic, so that you have more of an efficient Kafka topology, and you can consume the messages faster and only the ones that you're interested in. But more than me explaining this, we can actually look at what the producer and the consumer looks like. So I just created a topic called as test. On the left hand side is my producer, as you see, producer, and on the right hand side is my consumer. So all I'm doing over here is, on my producer, I'm saying that I have a broker or a Kafka server running at localhost 9090, which is what I had started like a few minutes ago. I want to connect, or I want to push my messages to topic test. You have ability to provide more options like partitions, etc., etc., but I'm not going to get into that right now. Also, we just have a single partition topic right now. And then on the right hand side is the consumer side, where we are saying that like, hey, the Bootstrap server or the Kafka server is available at localhost 9090. I want you to subscribe to the test topic, and I want you to start consuming from the beginning. And I want you to be a part of a group called as test group. We are going to look at what the test group is, and the from beginning is in right after this demo is done. So let us first start the producer. And this is one of the important and cool concepts of Kafka that I'm going to demo now. So like a real quick drum roll, because once the producer starts, essentially now the producer has started, I can go on publishing messages. Okay. Now imagine this, that if it was a synchronous system where you can't publish a new message till the previous message is consumed, remember, I still haven't started the consumer. I would not have even been able to produce message 2, 3, 4, 5, 6, 7, 8, 9. That's because the first message is not yet consumed. What Kafka allows you to do with this whole pub sub mechanism via abstracting it out at a topic level is the producer can produce at its own rate and the consumer can consume at its own rate, and we have successfully decoupled the producer and the consumer. So imagine this like being a REST-based system where the producer publishes the message to a consumer via a REST call, but the consumer is down. Then now it's up to the producer to figure out how to handle the errors. Like, do we not produce the second message? Do we store the failure somewhere? Do we alert the user, etc., etc.? But by decoupling the producer and consumer, what we have successfully done is the producer can produce at its own rate and the consumer can consume at its own rate. So for example, I can now start actually consuming from the beginning, and once the consumer starts, it should consume all the messages from 1 through 9. Yeah, there you go. So it consumed from 1 through 9. And now, because the consumer is active, I can go 10, 11, 12, and you will see that the consumption is going on out here. Now, let's say in the event that the consumer actually goes down. So I just killed it right now. And let me, I'm not going to clear it right now because I want you all to see what this from beginning does. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Now, if I do 13, 14, 15, 16. So essentially, if I start the consumer again, it is the expectation of us that like, hey, because we are saying from beginning, it should start consuming from 1 onwards. However, what that from beginning means over here is it should start consuming from beginning if this is the first time, or if there is no information on Zookeeper about the offset to which this group has consumed. So in simple words, we have already consumed the first 12 messages, and this data is available with Zookeeper. And because it is available with Zookeeper, what Zookeeper is going to say is, hey, while you were gone, while you were not consuming, there were only messages 13, 14, 15, 16 produced. So let's see how it looks like. So that's why I don't want anyone to be sort of get taken aback by what is from beginning in this case. So I just hit enter, and you can see we only consume 13, 14, 15, 16. And now the way Kafka does this, like understands that only 13, 14, 15, 16, these messages are left to be consumed by this consumer group, is by a concept called as offsets. So there are two concepts that I need to explain right now, and I will explain them and then we'll get back to this demo. The first concept is called as, so the first concept is called as consumer group, and this is a part of, sorry, I'm at the wrong place. Yeah, over here, consumer group. All right. So essentially, if you remember here, I gave the group called as test group. So this group is nothing but a consumer group. A consumer group is a way in which Kafka understands that which group which group is this particular consumer belonging to. And where consumer groups come into picture is every consumer group gets the message, okay, gets the messages which are not already consumed. And the reason why this is very important, and unless and they are not already consumed, the definition of not already consumed, I will explain while I'm explaining offsets. And the way every consumer group actually plays a part in this entire Kafka ecosystem is that you can have one producer and multiple consumers consuming from the exact same topic. So essentially, if I were to start another consumer over here, so let me just create a new window out here. And what I'm going to do over here is I'm going to pick up this entire command, and using this command, I'm going to say instead of group, I'm going to say group one. Okay, so this is a new consumer that we are attaching to our same Kafka topic called as test, but this is a completely new consumer group. And in this case, because this is a completely new consumer group, it will start consuming from the start. So we'll get everything from message number one. Now, where the consumer groups come into picture, and once, yeah, so we got all the 16 messages. So if you see here, this is up till 16, this is also up till 16. And I know it sort of becomes very interesting while looking at shell scripts, but this is our producer. We are going from 1 through 16. This was our consumer, the very first consumer. This is our second consumer, but they are different using the different topic. So essentially, when there are multiple consumers consuming from the exact same topic, consumer group allows to decouple the consumers. So what essentially Kafka will do is Kafka will deliver messages, not messages that are not consumed by a particular consumer group. And we will see that we already saw it, where I basically just consumed 1 through 16, that the messages that were not previously consumed by this new consumer group. So now if you see, if I produce a new message called as 17, then you will see both of these consumers are actually consuming. Now, if I bring this consumer down, which was the very first one belonging to the group called as test group, let's see what happens on the other consumer group. Remember, the other consumer group or the other consumer is still active, and that one will go on consuming the messages 2021. Like, there is no decoupling of these messages. Now, if let's say this consumer was to come back up, then while this consumer was gone, we have produced messages 18, 19, 20, 21. Kafka will make sure that we deliver those 18, 19, 20, 21 out here. So there you go. Only these 4 messages were delivered, and at the same time, there was no change in this consumer. Okay, and the way Kafka does this is via consumer groups. However, now the question will be, hey Nikhil, how does Kafka know that only these 4 messages were not received by this consumer group or by this consumer? So that is achieved by a concept called as offsets. Okay, so essentially offset, or you can you can look at offset as a unique identifier for every single message. Okay, in other words, an offset is nothing but an ID for every single message in a topic and partition. Okay, so what Kafka essentially does is every single time a producer produces a message, when we did message number 1, 2, 3, 4, etc., etc., that gets an offset. And the offset is, an auto incrementing ID, so to say. And because, as I mentioned before, Kafka was nothing but a transaction log, what happens is this particular offset, the offset ID or the offset number, connects to the particular message that was published. What Zookeeper does, this is going back to where Zookeeper maintains all the configuration. What Zookeeper does is whenever a particular message is published, it ends up figuring out what is the offset of that message, and it knows what is the highest offset in that particular topic and partition. When a consumer starts consuming a particular from a particular topic and a partition, what Zookeeper does is Zookeeper says, hey, what was the last offset that this consumer has consumed? I will start giving the messages to this consumer between the last consumed offset to whatever is the highest offset that is available. Let me write it down again, just for reference. So each offset or each message has an offset. Okay, has an offset. Zookeeper retains or or has the configuration or has the store. So essentially, Zookeeper retains the highest consumed highest produced offset. Sorry, produced offset for a topic and partition. Zookeeper also retains the last consumed offset for a consumer group. Okay, now because the previous and because it contains the highest produced on the topic and partition, and it contains the last consume offset for a consumer group from a topic and partition, when consumption starts, depending on the configuration, uh, Kafka will deliver the messages between the last consumed to the last available, or to the latest available offset. Okay, that's how the consumer groups and offsets come into picture, and that's how Kafka understands that, like, hey, these are the messages which are pending to be consumed, so let me start consuming them. Now I'm going to
One
pause.
question. Oh, perfect.
Yeah.
I was just going to say there was one question that needed to be asked now at the same time you said you're going to pause for a question.
Yeah.
Can you talk about how this works when you have multiple consumers figuring out who gets what?
Perfect. Okay. It's like a nice segue for the next part. So is there any other questions, or
there are, but nothing that can't wait until the end.
Okay, perfect. So let me then do exactly that. So whoever asked that question, thanks a lot, because it actually helps me, show what I was about to show. So what I'm going to do in front of everyone is I'm actually going to kill both of these consumers so that you will be able to see. Okay, so clear. Okay, now what I'm going to do is I'm going to make sure that both of these consumers attach to the same consumer group, which is the test group. Okay, so test group, and once both of them start, I can show you what exactly happens. And this goes back to one of the things which I mentioned at the first, where only one consumer can consume from one partition, but one consumer can consume from multiple partitions. And I know it's like very difficult and convoluted when I say the same thing in a different way. So I'm going to write it down once more so that folks understand. So I know that both the consumers have started at this moment. So let me write that piece of information once more. Okay, so one partition, or rather, let me do it on the consumer side now, because I tried doing it from the partition side before. So one consumer can consume from multiple partitions. Okay, however, there can be one and only one consumer consuming from a particular partition. Now, because of this, and the reason why Kafka does this is to make sure, like, one of the contracts that Kafka has is Kafka guarantees ordering. So basically, in order to guarantee ordering, that's the reason why this is extremely important. So in a sense, to answer the question in a short way, is because I have I have two different consumers consuming from the exact same test group, exact same consumer group, it will be only one of them will be getting the messages consistently. And let's look at that. So 22. So if you see here, this is the one that gets it. Now, if I'm to go back to, I think, the Zookeeper logs or the broker logs, but okay, so if you go back to these broker logs, you will essentially see a lot of information. Now, in this information, there is there is a line over here which says preparing to rebalance group, test group. So what essentially ends up happening is, and I think it will be easier for me to now kill one of the groups, and let me actually kill the group which is connected to that particular partition. So let me kill that group. And once I've killed that group, within about 10 to 20 seconds, it will trigger a rebalance. And because it ends up triggering the rebalance, so if you see here, preparing to rebalance the group. Now what has happened is this has stabilized the group, and the assignment was actually now done to the other group, which was active. So essentially, now I can go produce another message and it will be delivered to this one. Okay. Now, here is another interesting thing. Kafka tries to be extremely opportunistic when it comes to rebalancing. So rebalancing is something which is indeterministic. Like just because now I bring this consumer back up, it does not necessarily mean that this consumer will start getting the messages again, because that was the consumer which was receiving the messages in the first place. And if you go here, you can see now the assignment is received, but there was no rebalancing triggered again. Okay, so it's again, it's extremely indeterministic, and so that's another reason why your consumers in the same consumer group should actually have the exact same configuration. So I don't know, but yeah, in this case, Kafka honored that, like, hey, this came back again, so that's why it rebalanced, and now it is giving the same messages back to this exact same consumer. Now let's actually bring down all these three, all the two consumers and the producer, because I want to show another side effect of this particular behavior when you have more than one partition. Okay, so let's say, and actually, you know what, let me switch to Java because it's easier to show it with Java. And then after that, I'll pause for all the questions. So what I'm going to do now is, in this case, and again, this is Java code. This is extremely straightforward, similar to what I had done via command line. I just have localhost, etc., etc., and I'm creating a new producer record and publishing it to a topic called as test1. I still haven't created my topic called as test1. I will be creating it in a moment, and then you will see. And also the logs are easier to read when I'm bringing up the Java client, because you can see the rebalancing, etc., happening. And essentially every 1 second I'm producing these 100 records. Okay, so fairly straightforward, not a very big deal. And again, I'm not giving a particular partition that it is connected to. So far we have only looked with only looked at a topic which had one single partition. So what I'm going to do now is I'm going to create another topic called as test1, which has more than one partition. Before I do that, I also want to show the consumer side code. Again, it's connecting to the same local host. It's going to be string, and it's the group ID is test group 1. Okay, I'm not giving a particular partition at all over here. So let's see exactly what ends up happening. And because copy paste wins, I also have a consumer 2. It is literally the copy paste of consumer 1, no difference at all. But it is again reading out of it belongs to the same group ID called as test group 1, and it is going to be reading from the same topic called as test. Okay, so now this is a case of we have one producer, two consumers, okay, from a topic, and I'm going to create a topic where it is going to be what was the name of the topic again? It's test1. And in this case, I'm going to have more than one partition. Let's make 3 partitions. Okay, just so that I can show another concept real quick, and then I'll pause for question. So I'm going to create a topic called as test1, and let's get that created. All right. And what I'm going to do now is remember that there are 3 partitions available on this topic. In this case, I'm actually going to bring up the consumers first, because I want everyone to look at the logs and understand what is going on. So it will start, and unless I have made a Some colossal mistake. All right. Let me start the other one as well. Okay, and what I want to show you over here is you can see that out here, uh, it's actually again assigning and rebalancing. And let's actually look at the code of the consumers, because over here at the consumers, I'm actually printing out the partition from which it is consuming. Now, so far, I haven't written out any messages, and because I haven't written out any messages, it hasn't consumed anything. So let's actually start the producer and produce messages 1 through 100. So it goes 0, 2, 3, 4, etc., etc. So you will see here, this is partition 1 and 0. And let me actually bring it back up. So consumer 1 is attached to partition number 0 and partition number 1, and consumer 2 would be attached to partition 2. Now, I didn't do anything over here. Now, what I'm going to do is I'm going to take another consumer, consumer 3. Okay, and again, consumer 3 is the exact same copy of whatever I had done before for 1 and 2. So let's start out with consumer 3. And okay, so now what Kafka will do is Kafka understands that, hey, there are 3 partitions available, there are 3 consumers available. So Kafka will automatically rebalance it. And now if you see here, consumer 3 is actually consuming from partition number 1. Okay, so 1, this is consuming from partition number 2, and this is consuming now only from partition number 0. For the sake of this demo, I'm not going to bring down the consumers. I'm going to just clear my sys out, so to say. And in the producer, actually, let me just restart the producer because it will start from 0 onwards. So 0, 2, 4, blah, blah, blah. 6, 8, and I'm only producing the events. So you will see here, consumer 1 is attached to partition 0, consumer 3 is attached to partition number 1, consumer 2 is attached to partition number 2. Now let's say your consumer 2 goes down. I'm just going to stop it, right? Now Kafka will trigger a rebalancing, and either consumer 1 or consumer 3 will get partition number 2. Let's see which one gets it. And we won't know that till we actually. Okay, consumer 3 got it. So if you see here, it is getting partition 1 and partition 2. Now, let's say consumer 2 comes back up. Okay, in that case, Kafka will rebalance it. But if you see here, now it is getting partition number 0. Okay, so it is extremely indeterministic which particular consumer will get a particular partition unless you forcefully tell Kafka that I want to subscribe to this particular topic and this particular partition. Kafka allows you to do that as well, but I don't want to get in depth of that. What I'm going to do now to prove this note which I had made is one consumer can consume from multiple partitions. I already proved that. However, there can only be one and only one consumer consuming from a particular partition. What I'm going to do now is I'm going to create a copy of consumer 3. Oh, I already did that. But again, just for the clarity, I'm going to show it to you that this is the exact same copy of consumer 3, and I'm going to run this. And I can similarly have consumer 5, 6, 7, 8, 9, 10. It doesn't really matter. Consumer number 4 has come up. So now we have 4 consumers. Okay, let me clear this. Let me clear this and let me clear this. So we have essentially 4 consumers. We have a topic with only 3 partitions. Let's see what exactly happens in once I start producing the messages. And again, we are only producing to 3 partitions. So I'm going to stop and restart the producer. So we'll start it from 0, 0 to 4, blah, blah, blah. So let's see. This consumer 1 is connected to partition number 2. Consumer 2 is connected to partition number 1. Consumer 3 is doing nothing right now. Consumer 4 is connected to partition number 0. So as you can see, at any given point of time, one partition is connected to only one consumer. Now, if I were to stop this consumer 4, Kafka will understand that, like, hey, I used to have 4 consumers, now I have only 3. there is one consumer which is like, remaining. Let me start giving the messages to that consumer. So rebalancing will take place. And so now consumer 3 is getting the data. But the interesting thing is consumer 4 was connected to partition 0, but consumer 3 is now connected to partition number 2. Again, this is something which like, Kafka does internally using its own algorithm, unless and until you force Kafka or you force your consumer to a particular partition. I hope that answers the question, and thanks a lot for anyone for whoever asked that question, because that was a nice segue to the second half of the getting started with Kafka talk. Let me quickly recap everything that we covered so far, and after that I'll hand it over to Jean to ask me questions, and then we'll go. Well, I'll try to answer them one after the other. So in terms of summary, Kafka is a transaction log, which ensures data is delivered or ensures that messages are ordered in a particular topic and partition. Two, Kafka topology consists of zookeeper, broker, topic, producer, and consumer. Let's do the Oxford comma here. Producer and consumer. Then again, going back, producer and consumer systems are completely decoupled, thereby allowing the producer to produce at its own rate and consumer to consume at its own rate. Okay. Last but not the least, more actually second to last, more the number of partitions in a topic, more is the availability of parallelism on consumption side. Last but not the least, one consumer can consume from multiple partitions. However, one partition can send or can however, one partition can send data. I want to word it correctly so that it's slightly different, but I think the one that I wrote above is the best one. However, there can only be one consumer consuming from a particular partition. Okay, I think we did see one more thing. I'll just note it for our benefit. Because of the decoupling of the producer and the consumer, you can have more than one consumer system via consumer groups, consuming the same messages at their own rate. Okay, I'll pause now and hand it over to Jean for questions.
Great. We have a bunch of questions. Two
Sure.
of them were about partitions.
Okay.
If order is not important, should you have more partitions?
So then, so partitions and ordering are not essentially, interconnected. Partitions, consider partitions to be a way in which you can achieve parallelism. So irrespective of if order matters or not, you are going to get ordering, because that's the whole, the whole property of the system. And because of that, like if ordering doesn't matter, you can add more partitions, but then you have to add more consumers as well to allow the parallelism, the necessary parallelism.
Okay. And can you repartition a topic once it's created?
Yes, and an extremely good question. You can always repartition a topic. However, rebalancing doesn't happen at real time. So what that means is, if let's say I were to, I thought I had essentially, yeah. So you can always alter the partitions. So let's actually do that live. So if you remember, my very first topic called as test had a single partition. So I'm going to I'm going to essentially alter it. Alter. Oh, sorry, I copied the wrong thing. So let's copy this. Okay, so I'm going to alter the topic. The name of the topic is test, which had only one partition before, and I'm going to create 3 partitions. Now, before I do that, extremely important is I actually want to bring up my producer again and my consumer. And this is very important because uh, this is something which most systems uh, discount while they are repartitioning the topic. What happens is, because of the dynamic natures of the topic, like or the dynamic nature of Kafka more so, is the moment you alter the partition, okay, uh, if you already had messages available, Kafka does not go and redistribute those messages across these new partitions. And you will see that you actually get a very user-friendly message the moment I add more. So if you see the partition that has a key, the partition logic, the messages will be affected, but they're only affected for new messages. And now, essentially behind the scenes, it's advisable that you actually restart your producers as well and your consumers, so that they can start getting the messages from that particular topic. And what I'm going to do is, I'm not going to restart my consumers because the rebalancing still has not happened, and I'm going to start producing the messages. Okay, 34, 5, 6, 7, 8. Okay, if you see here, I'm actually producing these messages 1, 2, 3, 34, 5, 6, 7, but only this consumer is consuming 1, 5. And that's because what has happened is the rebalancing has not happened towards the consumer side. So if I just restart this consumer, now Kafka will connect that consumer to the new partitions, because this consumer was already up while the topics were altered. I hope that helps and that makes sense.
How do you prevent Kafka from filling up when you never remove messages, and/or when do messages actually get deleted and go away?
Yes, so Kafka has a default retention. I think I don't remember at the top of my head, but I think the default retention of messages for every Kafka topic is per partition 500 megs or 7 days, whichever comes early. Also, the retention period is completely dependent on the amount of disk space that is available. So if your disk space is full, like I mean, right now this is just writing logs over here. If suddenly my disk space gets full, then on the producer side, I'll start getting messages that, hey, I can't publish more information. But again, everything is configurable and you can configure it.
If you're on a shared file system, is that a problem for storing messages?
Again, like it from a Kafka perspective, it doesn't matter, but I'm pretty sure your sysadmin will not like it, because it's essentially what you're saying is you're going to keep on storing all of these messages for like the the logs for Kafka is essentially on a shared system, and you can only keep as many messages as your disk space is there. So generally in like in production or in a shared environment or in an integrated environment, more so, you have like dedicated nodes just for Kafka. So you'll have like a, a like probably a 500 GB node or something with like in a clustered environment, so that the messages are distributed, etc., etc. And again, like disk space, right? It all is dependent on disk space. So
what about latency? Like, just try checking out from Subversion back in the day to a shared drive. It's really unhappy. Does Kafka have problems with that?
So again, with Kafka, if you're looking at pure latency between the producer and the consumer, I think there were tests done. I don't remember the actual latency numbers of the top of my head, but it's definitely something that you can find after Googling. But the one thing to note is that the information from the producer to the consumer, or rather a message is available for consumption only after it's written in the file system, in the logs. So if you are, let's say, on a shared drive or something like that, and you have to actually, like, the producer publishes a message to the topic, then the topic has to do some network interaction and publish it, push the message over like the network to, let's say, some other data center or something. Then only when the message is written, the consumers will get it for consumption. I
Okay.
hope I hope that makes sense.
It does. We had a couple of other questions about performance as well.
Okay.
How many topics in your experience can you have before you start hitting performance issues?
So because Kafka decouples everything, and if you look at the way the actual configs have been stored, they are stored on Zookeeper, where Zookeeper has just pretty much I shouldn't call it pointer, but for a lack of better term, like, it has a pointer towards a particular consumer group and a particular what do you say, offset. That's why, like, in my experience, we have had like close to about like 150 odd or 200 odd topics, before which we had to actually migrate from like a particular cluster to like a bigger cluster, just because we were filling up disk space. Like, it was a problem more of a disk space than of latency.
Okay. How do
Yeah.
you ensure the consumers are fast enough so that the transaction log doesn't keep growing indefinitely?
So, an extremely good question, but also a wrong question at the same time, and I'll explain why. Because as I'm like, so, and this is something I want to write it down here so that folks remember it. So, question question was how to ensure transaction log is not filled for slow consumers. Okay, so first and foremost thing, Kafka does not care. Okay, Kafka Kafka does not care about how fast the consumers are. Okay, and this is very important. And the reason why it's important is because producers, consumers uh, are decoupled are decoupled via a topic. Okay, so now if a particular consumer is super slow, also you have to take a step back and think about where do you use Kafka. You use Kafka for close to real-time messaging, not as a database. So that's why, even though Kafka is like a transaction log, it does not mean that like you're using it as a database and you are actually having a transaction log of like a consumer, like, logging in, like hitting the database, etc., right? So when I say transaction log, that's the property of Kafka. It doesn't mean that it's like an actual, like select star kind of a transaction log in terms of a consumer. Now, because these two are decoupled, if Kafka evicts, let's take an example. A particular topic and partition has, let's say, 500 messages. Okay, and a consumer has only consumed if I can type, consumed 100 messages. Okay, now let's say you are beyond the retention period of Kafka, and Kafka is going to end up, purging like 499 messages. Okay, 499 messages will be purged. But just because there is a consumer which has not consumed 399 messages does not make Kafka not purge it. So 499 messages will be purged because they hit the retention, policy, irrespective of if they were consumed or not. I hope that makes sense. And this is extremely important.
Can you briefly compare Kafka to JMS?
In 2 minutes, no. I would only say it also depends on the like a few things that I would want to note is I think comparing Kafka to JMS might be sort of a wrong kind of a comparison. Like you would want to compare sort of Kafka to like a system like MQ or something. And I did a talk called as RabbitMQ versus Kafka. So folks are welcome to look that up. But apart from the shameless plug, my personal opinion is I prefer Kafka. and that's mainly because again, it's a fairly mature system. It allows you to do a ton of things in a ton of configurable ways.
Okay. And when you did the multi-consumer demo, neither consumer saw all the messages. Is it intended that neither one has a complete history of what has occurred?
No. So when I did the multi-consumer demo with both of them connected to the same topic, right?
Mm-hmm. Yes.
And same consumer group. So in that case, when it's a multi-consumer ecosystem, where if there are multiple different consumer groups, then a particular consumer group will get all the messages. But if all consumers belong to the exact same consumer group, Kafka will make sure that there is parallelism. And then depending on which partition a particular consumer is connected to, you will get messages in an ordered fashion. And that is the reason why any Kafka consumer has to be idempotent.
Okay.
And what idempotent means is if you rerun the same messages over and over again, the state of the system should not change.
Is there anything you can say about Zookeeper free Kafka?
Sorry. So there is a lot of I think there's a lot of movement going on where like there have been and I think the Confluent folks are better to answer that question than myself because I don't work for Confluent. But I know for a fact that there has been like enough material published as well as enough blogs out there where there have been discussions about having a Zookeeper-less Kafka. But as of this moment, you need Zookeeper.
And I think this is the same question. When do you think that KIP 500 will be finished?
I don't know. Again, I don't work for Confluent, so.
Yeah.
Yeah.
But you confirmed it was the same question.
Yeah.
The next question is, someone said, it's still unclear to me how purging messages is compatible with guaranteed delivery so long as there are n-1 servers.
Good question. So maybe I should change my, change my statement out there. So guarantees delivery as long as servers are available within the message retention policy. How about that?
That actually helps. That makes it more explicit what's going on.
Yeah.
And
thanks a lot to whoever asked that question because I'm going to make sure in my next presentations I keep that.
And we've made it through all of the questions.
Oh, that's perfect. Thanks a lot, Gene. And thanks a lot, everybody, for attending Getting Started with Kafka. Again, my name is Nikhil Nanivadekar. Hopefully, all of you have a wonderful Monday. You guys can look at, everybody can look at, eclipse.org/collections, as well as you can follow me on Twitter, Nikhil Nanivade, at Nikhil Nanivade. With that, I'll hand it back over to Gene. Thanks a lot, everyone.
Our next session just started. It's Fabienne's talk on machine learning, and I posted the link in the chat. See you there.